Now that we've done our multiple regression analysis with Excel, we can use it to help answer our next few questions. So evaluating the equation ANOVA, multiple standard error of estimate, and coefficient of multiple determination. Using the information from the ANOVA table in the previous example, calculate the multiple standard error of estimate and the coefficient of multiple determination. Interpret what these numbers mean. So if we have a look in our formula sheet, we'll be able to find formulas here. Multiple standard error of the estimate, so fortunately, if we have a look here, so this is actually found in our ANOVA. It's our SSE. So we've got that included right here. So we had our standard squared here, and if you remember when we did our ANOVA table, that was the second number here. So we can use this number. Copy this. So we have the square root of 46.98 divided by n. We have 5 observations minus k. We have 2 columns or 2 variables plus 1. So we would have this would become 46.98 divided by 2 and we can take the square root of it. And we get 4.85. So now we have a multiple standard error of estimate of 4.85. And what does that mean? So we need to interpret what this number means. So essentially this is similar to our standard deviation. So if we were to take our observation, if we were to input something into our multiple regression formula here, and we wanted to test whether that this would work for a student, we could use the multiple standard error of estimate as a standard deviation. So we can expect, in this example, the student with 4 hours of study time and 6 classes attended to get 75.7%. We can give a standard error of estimate of 4.85. So that means it follows the same rules that our standard deviation did, meaning 67 or 68% of observations will fall within plus or minus 1 standard error of estimate. 95% will fall within 2, and 99.7 will fall within 3. So it works in the same way. So now we need to calculate our coefficient of multiple determination. So we can go up to our formula sheet. We can grab our formula. So this again is found from the ANOVA table. And we have our SS total, our standard squared total, and our SSR, which we can find our standard error regression here. So we can enter this in. And we get 0.9718 or 0.9718 for our coefficient of multiple determination. So in other words, 97.18% of a result of y can be explained by our model. And that would leave about 2.82% of unknown factors that are determining what is happening. So we can say that the study time and the class time has a 97% impact on, can explain 97% of how someone gets their grades, leaving almost 3% to other unknown factors.